Hello. Can you hear me in the back? Yes? Hi, everyone. Thanks for joining our panel on reinforcement learning to make LLMs as useful as possible. So before we start talking about reinforcement learning, I'm going to first let both of our distinguished experts present themselves. Jacopo, do you want to start?
Hello, everyone. My name is Jacopo Poli. I'm the CTO of LightOn. LightOn is a French startup. We build a platform for generative AI for large enterprises. The idea is that these companies have two issues, privacy, and they need to be guided in using generative AI, and that's what we offer. We deploy on-premise for large companies, and then we help them use generative AI in their workflows.
Thanks, Jacopo. And now, Alexandre?
Well, thanks for having me first. So thanks. I'm happy to contribute to this great event. So I'm Alex. I'm leading the research team of InstaDeep. So we are a startup specialized in, let's say, innovation and applied research. So with a specific focus on reinforcement learning. So we're helping our customer build custom solution for them. For example, in fields such as transportation, logistics, supply chain. We work with, for example, actors like Deutsche Bahn in Germany to help them build and manage the dispatching of trains over there. So all the solutions are very advanced, so we need a kind of strong research team and research arm in the company, so that's what I'm leading. The company is around 350 people, and the research team is around 40. So the focus of our team is twofold. The first one is on decision-making AI, where we do a lot of reinforcement learning, like I mentioned, but also, and more recently, in the last 2 years, we have developed a lot of expertise in machine learning for biology, especially due to our long collaboration with BioNTech. So I think you all heard of BioNTech because they were the first to successfully deliver a SARS-CoV-2 vaccine and spread it to the world. And so we've been working with them for the last 2 years, and they just recently acquired us in July of this year. So we're very excited about that, and let's try to empower them in their mission of personalized vaccine for the world. So we're very excited about that, and we keep also obviously working with all our customers and developing products for them.
Thanks, Alexandre. Cheers. So why are we talking about reinforcement learning today? Well, to start with, in the benchmark conducted by Berkeley on the top LLMs, the top 3 incorporate reinforcement learning. And why is that? Is because I think all of you who are working on models know the challenges with predictability of responses, with how the model drifts, and how do we make sure that it responds correctly in the best way, reduce the number of hallucinations, and so how do we build feedback loops so the model continues to learn about how to respond in an optimal way. So we're going to talk about what is reinforcement learning in a bit more detail. We're going to talk about the technical challenges of reinforcement learning. And then, not just technical challenges, there are also business challenges around reinforcement learning, which means that a number of people are looking at alternatives in terms of honing models to these kinds of technologies. We're going to look at forward thinking. What are the future trends in reinforcement learning? And then I will hand over to both of our speakers for some special announcements. So let's start with, what is reinforcement learning? Alexandre, can you tell us?
Yeah, of course. So first things first, yeah. So RL, I like to say that reinforcement learning is the problem of controlling an unknown system. So that doesn't mean much. So if you try to be a bit more concrete, reinforcement learning try to train an agent to solve sequential decision-making problems, right? So if you take the classic analogy of playing chess, for instance, you have an AI agent playing against itself. It generates games, and it plays move and change the configuration of the board step by step. At the end, the agent receives a reward signal, which is either, for example, +1 if it's a win, -1 for a loss, and 0 for a draw, for instance. And then over time, you hope that the agent will start identifying patterns such that some patterns yield mostly a win or a loss or a draw. And it's going to start reinforcing these patterns to, at the end of the day, try to reach an optimal behavior. So it's we use a lot of games in reinforcement learning because they are very easy to simulate, and also the scoring function is very transparent. But reinforcement learning is a very versatile approach, right? It can be used on so many things. We use it at InstaDeep for, like I mentioned, supply chain, transportation, logistics. So it's very versatile. There has been a lot of success stories of RL, mostly by big tech companies. So, for example, OpenAI use RL to control robotic hands, Google Brain or Google X, I believe, use ARL to control stratospheric balloon, such that they can control the location, such that they can provide internet connectivity to some remote location on the globe. And then more recently, perhaps, we could say that ARL was also useful to make and contributed to make, for example, ChatGPT as successful, right? So I say contributed because obviously ARL is not all, right? There's a let's say, complicated pipeline here to reach the quality of ChatGPT. So obviously we know there is the whole part about the learning the base model and doing a lot of next token prediction on those models on a large quantity of data, perhaps of low quality, but large quantity at kind of internet scale. And at the end of the day, you end up with a model that can do text completion very well, but is not super useful. Then generally people do a next step, which is supervised fine-tuning, where they show a few amounts, so we're definitely in a low quantity regime, but very high quality of demonstration of how you would like your LLM to behave. How do you want your LLM to answer a prompt from the user? So that's already make the model quite useful, but not quite yet, right? So we changed the style of the answer of LLM to respect what you expect the LLM to answer to a given prompt, but still, it's still not super useful for a user, and that's why there's this last stage of using reinforcement learning to kind of align the model with what you would like it to, how you would like it to behave. And there, when you try to apply reinforcements for LLM, and it is what we call RLHF, it's a two-step process. The first step is, obviously, you have a pre-trained LLM, and you're going to start asking human evaluators to rank the solution or generated by a LLM given a certain prompt. Based on this ranking, what you're going to do first is train a reward model. So reinforcement learning need this reward signal, this kind of feedback loop as mentioned by Adrian, to be able to shape its behavior, reinforce good behavior that yield high reward. So the first thing to do is training a reward model. Based on that, now you're going to have an agent that's capable of evaluating, of assessing whether a given answer is, let's say, is going to be evaluated correctly by the human evaluator. So you want to maximize, let's say, the probability for human evaluator to agree with this answer. Once this is done, you can actually use reinforcement learning against this reward model. So you can simply use, like OpenAI used the proximal policy optimization method because they invented them. But you can use other RL algorithms as well. So you try to use reinforcement against this reward model to kind of slightly improve the capacity of your model to answer in a more appropriate way to the different prompts of that the user would provide. So that's the first thing, but of course you can also try to reiterate that process over and over again. Because when you don't want to over-optimize your model, because the rewards model might not be super accurate everywhere. It's generally accurate over distribution of answer your model can provide, but if you start changing your model, obviously you change the distribution here. So you want to avoid over-optimization, and how do you do that? You can, once you have fine-tuned slightly your model, you can ask again to the human evaluator to provide more feedback to fine-tune your reward model, and again, we apply reinforcement learning. So it's kind of a tedious process, for sure, but at the end of the day, that's what works better, right? As Adrian mentioned, in the top AI assistant in the world right now, so you have ChatGPT, Claude, and others, all of them have been, let's say, the final stage of the training has been RLHF, so it works very well in practice, because obviously it's try to align a bit more the output of the LLM with the human evaluators. So yeah, perhaps in the long form, this is RL and also how it's being used for LLM at this stage.
Thank you, Alexandre. So let's get into the technical difficulties or challenges of implementing these types of technologies. Jacopo, do you want to talk about these a bit?
Yeah, sure. So at LightOn, in production for our customers, we use a model that's trained with RLHF. In order to do this, there are different challenges to address. The first one is obvious. It's a technical challenge in terms of how to actually train the model. It's quite different from pre-training. Pre-training is, in the end, expensive but simple. You collect a massive amount of data. You initialize a super large model, and you just let it run. Provided you have a few hyperparameters set right, it's going to work. In RLHF, we have to juggle 3 models. These models They are active in different parts of the process. And you might have models that have different size. The reward model could be smaller, larger. There are people who do both. We do larger model for reward model because we think it's better. If you have a larger model, then you need to juggle the fact that that might not fit in the same node that you're using for the model that you're actually training on. All these kind of considerations mean that you have to, you add a dimension to the complexity of the parallelism that you have to implement in pre-training. In pre-training, you just have one model, you parallelize it across 3 different dimensions typically. Here, you also have to take into consideration that when you switch model, you have memory constraints that are a bit different. And on top of this, there is also the question of data. The thing that's a bit annoying about the free top models is that they're trained on data that's not disclosed. And this is actually the massive thing that makes this model have tremendous value. The thing is, models that are really capable, they're also much more capable in picking up biases in the data. And I'll make 2 examples to make you understand this. One of the examples that people do to teach how RLHF works is, let's train a policy with a sentiment classification reward model. So we want a model that always outputs positive sentiment. If we do this in a really naive way, we are gonna have a model that learns to output probably a lot of times the token great, 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 because that's really positive. But it's not what we actually want. And something that's even subtler that we've actually experienced in Open Assistant, which is one of the best quality datasets for RLHF in the open, in our experience. There are a lot of data in Spanish, and the data in Spanish are of really good quality. And then there are data in English that have a more even distribution of quality. If we don't balance the data, what we get in practice is that if we prompt the model with hello, the model will actually reply in Spanish, because during the training, we didn't address this bias. And the model, like the reward model, saw this data, said, okay, when I output stuff in Spanish, it's great, so let's output stuff in Spanish, which once again, it's not what we really want. So there are plenty of things like this that are really subtle and that often we only discover once we've trained the model, because even really subtle biases in the data then show up in an incredibly visible way when we actually use the model in practice. And the quality of data in the open, yes, there is Open Assistant, there are some other data sets, there aren't that many preference data sets, and the ones that are there, most of them also have feedback that's not actually human. That's GPT-4 or a system like that actually provided feedback. And in some ways it's okay, but then we have to also think that those models have been trained and they might have biases as well, so they will have an effect on the data that they generate. And also, in terms of the actual personality of the model, we can see when a model is trained on data that's like OpenAI, because they will do like the typical stuff that the open source community has learned to dislike, where they say, as an AI language model, I will not do this and that. So that there are all these kind of considerations to take into account. Besides the technical challenges, it's complex engineering. It needs quite some effort to implement. The data work is undervalued. And it's really, really important because the model is unusable if you don't take care of that part.
Thanks, Jacopo. Alexandre, maybe you had kind of some other aspects of technical difficulties in specific industries like biology for RL?
Yeah, I mean, we use RLHF less in the context of AI assistant, like Jacopo just described, but we use it a bit more for biology. So when you think about, for example, doing drug design or antibody design, what you might have is, let's say, a language model that can generate candidate sequences of, for example, amino acids, which is a candidate for drug design. And then what you would do then is you would test in vitro in a wet lab this candidate and get a feedback. But that takes a huge amount of time. So there's a uncompressible amount of time you have to spend to wait to get the feedback from the experiment. And there, again, there's a very large amount of noise. Depending on the calibration of the machine, depending on the scientists who perform the experiment, you might have a very large amount of noise. And so how do you do RLHF, or let's call it RLBF, like from biological feedback? How do you do that efficiently in that context? That require, again, other type of techniques, perhaps. You also probably want to, you're going to have multiple rounds of feedback you're going to collect, so you probably want to maximize the information gain at each iteration, as opposed to trying to get the best candidate from the get-go. You want to maximize the amount of information you get, such that you can, let's say, bring a lot of value and knowledge to your model for the next stage, right? So again, depending on the context in which you apply RLHF, other challenging arise, and that makes it quite interesting.
Thanks, Alexandre. I'm going to talk about a little anecdote I heard today about reinforcement learning. So somebody was telling me that LexisNexis, which is a very big database of legal documents in the United States, trained a model to find legal questions on all their documents, and they announced 0% hallucination. So, of course, it's an interesting stat. And so the person who told me the story said, he asked them, like, how did you do that? What level of reinforcement learning did you do? And so they said, well, we had 4,000 lawyers for a whole year who were testing the model. And so I think what's interesting with this question is now that we've talked about the technical difficulties, what are the business challenges of doing reinforcement learning? Is there a law of diminishing returns? You're putting a huge amount of effort in computing, in people, to get maybe incremental improvements of your model. And so how do you deal with that type of challenge, Jacopo?
Yeah, it's a really interesting question. A lot of people come to us and say, I'm using ChatGPT, it's incredible. I want the same thing for my company. I just want it on my infrastructure. And we're, okay, we are the guys for you. But how to go from this to actually deploying in practice? A lot of times these people have used the tool just in a generic way. The reason why OpenAI models are so great is that the model is treated like a product. And that means that every behavior of the model is designed. Like the fact that when we ask certain kinds of questions, we have a specific answer is really designed by the people who are creating this model. If you take any open source model and you go with a prompt that's like banana, you will have nonsense in the output. If you go to GPT-4 or GPT 3.5, you will probably have a funny answer, like, okay, bananas, and make a joke about it and go on with the thing. And this is dumb, but for people that are outside of the technical field, is really a game changer because it allows them to understand and interact with the system much more simply. So in terms of business challenge, the real challenge is actually define with our customers how should the system behave. And the other thing, for example, is they are tools that are very cultural. Like the way GPT-4 speaks, you can see it's American. It's not the same way that French people speak or people in the Middle East speak or Chinese people speak. And this thing, at some point, gives a certain sense of feeling just not right. Like it's really good, but it's just missing that last percent that makes it really sound like something human. So this is actually what people, like we focus on with our customers. It's like definition of the behavior of the model. And from there, then we can work to deliver what they want.
So in a way that incremental improvement is worth it because it generates business.
Yeah, exactly. Model. Then there is the question of the like trade-off between spending so much time defining like the perfect system, which does not exist, and instead defining precise deliverables that we can act on and we can measure. But this is just, I mean, normal, good, let's say, product design practice.
So we talked about the technical difficulties of RL. What type of alternatives are there to Hode models, Alexandre?
So, I mean, indeed, like RL is let's say, RLHF is a tricky pipeline to implement. So there's this two-step process that you have to iterate multiple times, getting the reward model right, and then optimizing using RL, but not over-optimizing and so on. So it is very tedious and probably quite expensive to do. So quite naturally, people have tried to move away from RL. and RLHF. And there have been some recent, let's say, success story there, notably some papers around direct preference optimization. There, they remove the need of this two-step process by instead of doing reward modeling and then optimization, they would directly do a regression task due to the fact that you can reparameterize your reward according to the policy of the agent. So you can directly optimize the policy such that you respect the ranking provided by the human evaluators. So that's very promising. I haven't tried myself, but it looks like a very simple approach that seems very efficient when you read the paper. So really looking to see how people are going to use that. I think it's quite amazing how fast the field is going. When you see that ChatGPT was released 1 year ago, RLHF become very kind of a thing on its own because of that. And now, a few months later, a year later, perhaps we've found a new method that's most likely gonna overseed RLHF. Obviously, having a reward model is interesting also for other aspects. Perhaps you want to do rejection sampling, do a lot of sampling to answer a given prompt, and use your reward model to rank those answers and take the best one. So having a reward model can still be useful for some aspect, but I think instead of trying to develop this very expensive pipeline doing RLHF, probably the first thing to try is this kind of new simplified approach that seems to work very well. And then perhaps it still doesn't satisfy your need, and you can go for the full RLHF approach because it still has its benefit, right?
Thank you. Quick question on something you mentioned, Jacopo, earlier, is how the open source community reacts to RL and the challenges there.
Yeah, let's say that in the open source community there is a part of it that doesn't like it because of the way it's used, typically. And it was not uncommon on Twitter, at least like until 1 month ago or so, to see people like, I hate RLHF because it's mainly used for safety purposes by large companies, and understandably because they are liable for what they do. While in the open source community, we can be a little bit more free. In reality, in our experience, RLHF is so much more powerful than supervised fine-tuning. The generalization capabilities that we get from RLHF, from very few samples, are insane. They're totally different from what we get from supervised fine-tuning.
Thank you. So Alexandre, you're in charge of research. So can you tell us a little bit about what you see the future of RL is shaping to be? What are the latest trends or the upcoming trends?
Yeah, for sure. I mean, I can talk also with respect to what we do at InstaDeep. So there is definitely one trend, especially in biology, where we use, let's say, LLMs, large language models for genomics, proteomics, and so on. There's been this amazing work by DeepMind around AlphaFold and the like, and that really started a lot of initiative in that space. So even though it's not LLM like in the context of NLP, you still can use generative AI quite a lot in the biotech industry. So that's what we're doing a lot at InstaDeep around genomics. We release actually on Hugging Face. So thanks a lot to the Hugging Face folks for making this platform. It's very easy to share our model there. We have, for example, the state of the art for large language models in genomics. So we do a lot of work there, and there's the whole work about multiomics and others that is just very interesting. But then more on the classic way of using LLMs and generative AI, I would say the most interesting aspect that I find fascinating is the use of tools with LLMs. I believe that empowering LLMs by using some tools or even other models is amazingly powerful. I think just last week there was this model called Lava Plus or something like this, where the team of researchers actually allowed the LLMs to call other LLMs. So, for example, they use the segment anything model from Facebook, from Meta now, and you actually have the LLM that is able to call another LLM to do the segmentation of an image, and then be able to use that result for let's say the reasoning of the LLM and ground a bit more the answer. So that's amazingly powerful. I'm still a bit frustrated from a just pure research point of view and the aesthetic of the solutions that these LLMs are being trained to use other tools using supervised learning. So you would give, either you do in-context learning where you provide example, perhaps a description of the tools, and you would hope that your LLM is going to somehow understand how to use that tools, but that's kind of brittle. And then you also have the other approach of giving demonstration, but perhaps fine-tuning your LLMs to learn how to use that tool. But again, there, it's kind of tedious to have to retrain LLM to learn how to use tools. We know that training them is not necessarily easy, even with parameter-efficient fine-tuning. So that can be a bit tedious. And also, like I mentioned, the aesthetic of that solution for me is not great. I would much rather try to use reinforcement learning to try to give the model this notion of task, and I give you tools, and you have to learn automatically how to use them to accomplish some task. And for now, that's not something that has been done. Everyone uses supervised learning and demonstration. I think it has a huge potential using AOL in that context. It's actually something we had done, like I think 5 years ago. We published a paper with Google DeepMind called Alpha NPI, where we show how, it was an LSTM back then, of course, how an LSTM could have call and compose sub-programs automatically to accomplish some kind of more complicated task. And all the sub-programs were learned. Everything the human had to do was simply to define the pre and post condition of each program. But the system would learn to solve each task automatically. So that's why I believe it's possible to train LLM using reinforcement learning to use tools as opposed to simply supervised learning. So that's what I'm very excited about, and I think that's going to be quite empowering for LLMs, and that's going to change quite a lot.
So just to kind of wrap up our panel, so talking about what's exciting you right now, that's what you're working on, and how InstaDeep is.
Yeah, I mean, it's very much aligned with that. I believe we did a lot of work on also having multiple LLMs debating. We know hallucination is a big topic right now. How can we help in terms of truth discovery? How can we make multiple agent debates such that you remove the display of hallucination, or at least you alleviate it quite a bit? And it's also it's quite interesting there. You can see that by modulating the level of agreeableness between the different models, you can see that you can actually improve quite a lot of performances. So we're working a lot on trying to articulate LLMs among each other and also start using other tools. So that's really something we're pushing strongly on.
Thank you, Alexandre. And so to finish, Jacopo, I think you had some things to announce today.
Yes. So at LightOn, we believe in an open core strategy. So our models, like the model to deploy to our customers, are actually open source. We're releasing a version 2 of the model that's trained with an increased context length with respect to the first one. That's like 8K context length. And in the next weeks, we're going to release the reward model and the RLHF version as well at 8K. And they're available on Hugging Face on Apache license.
That's awesome. Thank you, Jacopo. Well, that concludes our panel for today. Thanks, everyone, for listening to us. And I'm sure our two experts will be happy to answer questions outside. Thank you.